Okay. Next type of database is that Hadoop database, where this was originally developed as a result of the projects at Google and Yahoo. So they are the major companies where they adopted this particular Hadoop architecture for their projects, and this is going to have millions of indexing websites and quickly return search results for open source search engines. So majorly Google, we can call it as a search engine that is going to be used for that, and it is going to have millions of websites are going to be there, and when we are going to search for some particular data, so it should search quickly and it should return the result faster to the destination. So for that purpose, this Hadoop is going to be one of the tool that is going to be used from the Yahoo and Google companies. So the architecture goes like this. It is shown in the figure. There is two types of key elements. One is a Hadoop distributed file system, that is called as HDFS. A system is going to store the data across multiple nodes. So the nodes, it is being shown here. There is something about racks and all these things like this. Okay, and there is one more concept called as MapReduce. So this is an important concept where the data is distributed across the processing engine that splits a large task into smaller ones that can be used for running in parallel, so that the search can be faster. That is a major advantage. So here it stores how that it is going to store and process it. So it stores it that one in the HDFS, that is a Hadoop distributed file system. It's capable of handling specialized nodes in the cluster, including name nodes and data nodes. Now you can see here that this is called as data nodes. 1, 2, 3, 4 like this, and number. Then here is, these are the name nodes. It is going to be, the name is going to be there in this name nodes, and individual is called as a racks. The data is going to be stored, and there is a distribution switch is going to be there. So more than one processing units, there is a parallel processing is going to be done over there. So like this, the data is going to be split into the location, and it is getting processed also. That individual things that it is going to be shown in this, that is shows the relationship between the name nodes and the data nodes. How the data blocks are distributed across the clusters also. Now you can see in this, it is showing here that HDFS client, it is going to be there, and another is the client. This is a name node, and there is a namespace, and block management is going to be there. Individual blocks that it is going to be. Now here, this is a racks. These are different racks are going to be there here. Then we can see in this, the query is broken into. The query is going to be broken into smaller units and distributed across all the nodes running MapReduce in a cluster, then particular cluster that it is going to be. And while this is useful for understanding the patterns and trading in historical sensor or machine data. So here is some drawbacks are going there because of the time constraint. If it is not going to be given within that particular time constraint, this data back, so no use of that particular data. So to make it faster, this is going to be used for the applications, different applications. Depending on how much data is being queried and the complexity of the query, so both it is going to be considered. The result could take seconds or minutes to return. So it should be faster manner that you should run. So now you can see that there is a split up is there. There's a green, yellow and red, or different types of databases there, data, queries data it is. So all together it is going to be, the namespace are going to be there, and all these things are getting queried properly, and based on that it reduces the data and it is getting processed. If you have a real-time process running where you need a result at the moment immediately, so MapReduce is not the right data processing engine for that. So it takes a little bit of time, but it gives the proper results. Okay. This is the Hadoop ecosystems. So there's a ecosystem is there here. So where that how it basically processes that, it is being explained in this. So it plays an increasingly big role of the collection, storage and processing of IoT data due to its highly scalable nature and its ability to work with large volume of data. So it is going to have, it is basically capable of handling large number of databases, large volume of databases. Many projects have been developed to add incrementally functionality to Hadoop and have collectively become known as Hadoop ecosystems. Means it is not only one system, it is collective information. It is going to be known as Hadoop ecosystem. So there is one example, it is going to be there here. You can see that. The following one describes several of these packages and discuss how they are used to collect the processed data or process the data. Now you can see here Apache Kafka, Apache Spark, Apache Storm and Apache Flink. So by using these architectures, the data is being collected and it is being executed.